van Snel, heel lang geleden. Ja, ben ik altijd wel geïnteresseerd in praatjes vanuit Snel. Zeker sinds de laatste tijd meer en meer praatjes vanuit de kant worden gegeven. Dat is van harte aan te moedigen. En dus zat ik een keer op Twitter te kijken. Toen werd er ongeveer bijna live een praatje online gezet bij mijn domein. En ik denk dat praatje moeten we hebben. En ik zag diezelfde nacht nog. En nou, daarom staan ze nu ook hier mee. Welkom.
First of all, is there somebody that doesn't speak Dutch?
Okay. I will do it in English.
So, my name is Bauweraerts. I work for the company Mijn Domein. And I'm one of the persons together with Erwin that introduced Docker to the company.
I'm Erwin. I'm an employee at Snow. I've been working for Mijn Domein the past 2 years. First as a systems engineer, DevOps engineer, I've done it all. And last year we've been working together on getting a new platform running on AWS.
So a little bit about the company. We have a web hosting company in the Netherlands, one of the biggest. We have almost 600,000 domain for our customers. And yeah, we are still growing, so it's going very well.
A bit of background. Before we started this whole progress, we were running something called MD3, Mijn Domein Iteration 3, so the third software that we used. It was a monolith, one giant application, and there was about one release every 4 weeks, and those were night releases. Developer and some of them operations got up early in the night, about 2 AM, and they started with the release. It was a manual process, so they took an instance out of the load balancer, apply an update, check if it is working by editing your etc hosts file, and if it isn't working, the developer would go in the night, program a fix, test if that works. If it didn't work, mostly was the case, they tried again and they tried again, and so after 5 or 6 hot fixes in the night, there was a new version of MD3 online, and it was progressed. It took between 2 to 5 hours. Sometimes everything was working again at 7 AM in the morning, so it wasn't an ideal process. And about a year ago, we migrated, I think it was March 2016, we migrated to something more based on microservices. We had about 6 or 7 microservices. They were all running on 3 dedicated AWS EC2 instances. There were multiple releases every week. The developers could do it themselves. They used Ansible playbooks to update their code and the dependencies. And we used Console for service discovery in that environment. Console is a tool by HashiCorp. HashiCorp is also known for Vagrant and lesser known for Nomad and Vault. And what Console does is it provides service discovery. It enables this through a DNS server. So you can use the Console instances as a DNS server. And when you query a hostname, in the case of Console, the default settings are like your service.service.console, you get an IP address back of an instance that has that service. And it also does failure detection on those services. So it performs health checks on the services. It can be an HTTP call, it can also be trying to open a TCP connection or just running a command. And if that service isn't healthy, it also gets removed from the service discovery. So when you resolve DNS, it's automatically removed from the runtime DNS. It also provides a distributed key value storage with high persistency. So you can use it for key value storage that needs to be distributed, high available. It's also a multi-data center, which means that you can combine multiple console clusters. And when you do a DNS query for a hostname, if something in your current data center isn't responding fast enough, or if no service is healthy, it can provide host names from, can provide IP addresses of other data centers, so you can use failover all the data centers. There were some downsides to the system we created. It was very tightly coupled, so instances had hard dependencies on each other. It was expensive, because we needed 3 instances per microservice. Introducing a new microservice meant more instances. And introducing new services had some overhead. You need to write playbooks, input instances, updates, deploy scripts, create health checks. They were all manual steps. And it was high overhead, because not every service needs 3 instances to run, but for high availability purposes, we booted 3 instances.
So it was really expensive, so we looked for another solution. And the solution we thought it was Docker. But Docker wasn't run in production anywhere. Or, there were at least there weren't any stories on the internet or challenges they overcome. So we wanted to migrate. We wanted to migrate really slowly and controlled. So if something went wrong, we go back to the instances, and we just want to know how Docker reacts in production when the users come over. So we wanted to migrate to a platform that allows us to quickly exchange or remove functionality with high confidence without compromising the user experience or availability. So Docker. What is Docker? Docker, I'm just going to read it, it explains it all. Docker containers is a rapid piece of software in a complete file system that contains everything needed to run. And that's important stuff. It contains your code, your runtime, your system tools, and your system libraries. So PHP is included, for example, and extensions for PHP, and the code itself. So anything can be installed on the server as a side container. And it guarantees that the software always runs the same, regardless of the environment. And that's the reason MD3 needed a lot of hotfixes, because it works on dev, but it didn't work anymore in production. So this was a huge advantage that we didn't know before that it was possible. So we just gonna when going to Docker in production, we had some challenges, and we're just going to tell how we fix them. So the first one is building the containers. So the challenge was how do you test your code, build your container, have semantic versioning, and keep your containers clean with minimal effort and maximum optimization. So from Git to production, we pushed to a branch or a master. From the development, GitHub triggers are built with Travis. Everybody knows Travis, I guess. No? On Travis, we run our test suite. We create our container, and then we update the semantic version on GitHub with a tag. And we built the container and push the container with the same tag to Docker Hub, so you can see which version from code is the same as the Docker container. And then Travis triggers a container update on the accept environment. So when the build is passed, the container deployed to the accept environment. And that's how we build containers.
If there are any questions, you can feel free to interrupt at any time. We love to answer your questions. There will be a demo at the end, so we're going to go through this as fast as possible so we can show as much as possible. One of the next challenges is running your containers, because you have containers, you build them, and you want them running on multiple hosts, you want them to be highly available, you want to be able to update them, and you can just use Docker run on every machine, do it manually, but it's not really a scalable solution. So we looked at some orchestrators. Today I learned that OpenShift is also a really good alternative, but we didn't look into that. These were the options we mainly considered, and one more. Kubernetes is a very nice orchestrator. It's based on Borg that is used internally by Google. It has been used for the past 10 years. So it's really production ready. But when we started looking into it, it was quite complicated for the bootstrap. A lot of manual steps to get a Kubernetes cluster running. And it doesn't have a very good web UI. Web UI isn't the most important in the world, but when you're just starting out with a new system, it really helps to get a feel for what is possible with the system. We also looked at Nomad. Nomad is also from HashiCorp. And it has excellent integration with console, but it also wasn't really mature yet. I believe the release was 0.5 at the time, and it doesn't do rolling updates based on health checks. So it just, when you do an update to a container on Nomad, it will just start new containers, wait a set amount of time, stop the old containers and route all traffic to the new containers without checking if the containers came up correctly. So it is possible that you have a broken release, you push it online, and with Nomad it will just become the new containers that are running, and all the systems have checks to prevent that. We also looked at Docker Swarm. Docker Swarm is provided by Docker themselves. When we tested it, it wasn't stable. We lost port mappings. Sometimes host names wouldn't be resolved internally. Containers couldn't connect to each other, so that was rejected quite quickly. And there's also Amazon ECS. It's Amazon's hosted container solution. There's also Google Container Engine, Azure Container, and multiple providers of container solutions, but they will all have some degree of vendor lock-in, and we really want to avoid that. So we decided to use DCOS. It's a product by Mesosphere, and what DCOS does is basically provide an abstraction layer for multiple instances, multiple machines, multiple virtual machines, and you talk to DCOS, and DCOS is a combination of Mesos and Marathon and some other components, and they will schedule your containers on all your hosts for you. What DCOS does quite well is keeping the containers running. That's quite important, but it really does that well. The bootstrap is super easy. I will show the steps on the next slide. It's about 5 or 6 steps. It has a good web interface. With the web interface you can do anything you can do with DCOS, and when the option isn't present in the web interface, you can also edit the raw JSON to get all the options. There's really good logging, rolling updates based on health checks, something we really like. The downsides are DCOS has a lot of moving parts. I believe it's about 44 components that need to be running correctly. It has distributed state. What you see in the web interface can be different from what DCOS believes to be running, and that can also be different than what is actually running on agents. When testing, we have had 3 or 4 instances of that state becoming distributed and not consistent. Since running it in production, it hasn't happened yet. The web UI isn't always mature. The updates mostly fix bugs with the interface, but sometimes there are some regressions. For instance, now it isn't possible to remove startup commands from a Docker container. If you make it empty, it just thinks that you forgot to set it, and the last command you entered will be returned. There's no namespacing, so everything runs in one giant heap and can communicate with each other. And there's no way of running services on all agents. So if you want a certain service to run on all agents, like monitoring or something to route your requests. You have to scale it to the number of agents you have, set a constraint that it needs to be running max 1 per instance. And when you scale your cluster, you have to change the number of instances you want to run. These are the bootstrap steps. This really is it. You create a config.yaml, you provide your DNS recursor, your master IPs, and it needs a script to determine private IP addresses. You run a DCOS generate config script that will generate config files and install scripts. You can use Nginx for anything to host those install files. And on your masters, you retrieve that install script and run it with the command master. And on the agents, you do the same thing, but you provide it with the option slave. And if you do this, you can have your DCOS cluster set up in about 10 minutes, if you know what you're doing.
So the next challenge was environment consistency and configuration. So the challenge was mainly how can you guarantee that your code behaves the same on your development machine than in a production cluster. Because you don't want in your development, if you talk to a sandbox from a third party, and you don't want that in production, you want to talk to the real stuff. So how do you configure it? We use the console template. Console template, it's a little binary that you put inside the container, and it's the main process from the container. It watches the console key value store, and based on the key values, it renders a template, a configuration file, and after that, the child process you configured runs as well. And when the configuration is changed, console templates will signal the app that the config is changed, and you can run a command like clear the cache or something like that. So, and this the container it's really lightweight. For example, this was the Python application. It runs console template as main process and Python as child process, and that's it. So how does it work? You have console and Vault. Vault is a tool that manages your secrets, database, passwords, or something like that. And then console template is watching the key value store in the Vault. Then renders the parameter.yaml in this case. It can be anything you want. When it's rendered, PHP gets a signal, clears the cache, and then the new parameter.yaml is used, and the application is reconfigured. And that's it.
Next up is service discovery. In a container environment, you have containers that are getting rescheduled all the time. When you update a container, in most cases the container will be, a new container will be started and all the container will be killed. And you want that to be, be possible for all the containers to view those new containers. So for example, this is 1 PM, and 10 minutes later, containers have been shifted again, and 10 minutes later it can be completely different again. And this is a process that keeps on going every day. For instance, in the past month we had about 7 deployments per day. So it really happens like this. We use a combined setup. In the middle is Mesos. Mesos provides a DNS provider. But the problem of that is we only run stateless applications in DCOS, and everything that has state, like the database and Redis, is running outside of DCOS. So when you want to resolve those host names, you need something that knows those host names. So for internal communication, we use Mesos DNS. At the top, there's a container that wants to go to the Redis service, so it goes to redis.service.console, asks for an IP address of Mesos DNS. Mesos DNS doesn't know it. It uses console as a recursor, and console knows that that IP address is from Redis, and it will go back to the container. But when a container asks for a marathon.mesos address, Mesos DNS can resolve it directly and will just provide the IP address of the container that it is running on. And this allows us to, because Marathon also does health checks, and those health checks also have as a consequence that the services that aren't healthy will not be returned by Mesos DNS. So you always talk to healthy services.
And then logging. You need to know what's going on in your cluster. So you have to log everything. So how do you determine what's happening at the application level and domain level with minimal effort? So the application is really easy. You just log everything to yesterday out and yesterday error. And it's available to the web interface from DCOS with real-time. And we did some extra step. All the logging we logged also in Elasticsearch. So we have all the logs from container where we can look inside the Elasticsearch cluster as well, just for statistics and historical insights. Domain level, we use RabbitMQ. We are trying to move to that containers communicate with each other through events. And there is one consumer that takes all the events and stores them in Elasticsearch as well. And that's really, because all the events are stored, we know exactly what's going on. When something was wrong, we can look what's happened before, and we know really easy what's the problem. And we're going to demo this later on. So this is the setup. We have the DCOS agents and Docker daemon. Then we have a log stash. All the logs go to log stash, and log stash passes it to JSON, and it gets stored in Elasticsearch, and we can look to it in Kibana. For RabbitMQ, it's the same. The only step is that log stash has a real-time connection with RabbitMQ and takes the events from RabbitMQ and stores them in Elasticsearch. And that's logging.
Next up is request routing. We use AWS Elastic Load Balancers as an edge router, and we need to get the request to the correct containers. This is some example. When you request a front page of my domain, it needs to go to a certain container. But when you request a products page, a different container handles those requests. And there's also, when you want to log in, there's a different subdomain, it's also a different container. And we have about 8 containers that handle different parts of the web request. So how do you handle that? We use traffic. It says here pronounced like traffic, we call it traffic because the difference between traffic and traffic is easier to understand than traffic and traffic. It's basically the reason. And it has AE, so it looks like traffic. It's a HTTP proxy, reverse proxy. It can fulfill about the same roles as HA proxy or Nginx, but it can look at different backends, like Docker, Kubernetes, or in our case, Marathon, and it will look at metadata that you set on containers to set up routes to your containers. So you can provide a container with a rule that hostname needs to be www.mydomain.nl, and those requests will then be matched and go to that container. So you set the route on the container itself. And it's very dynamic, so when you do a rolling update of your containers, it has a real-time connection with Marathon, and it will be updated instantly. So this is the setup as we came up with it. We still use Nginx for certain requests, because traffic does not have the capability yet for redirects or for caching. So most requests go directly to a container, but certain requests are first routed to an Nginx proxy. That Nginx proxy will perform some redirects when needed. For instance, the HTTP to HTTPS redirect is handled by Nginx because it's not possible in traffic itself. And Nginx will also route requests to the containers that are behind it. And Nginx also runs as a container on DCOS. And this allows us to be very dynamic. For instance, we had a special Valentine's Day page at MineMine. The front page was pink or hearts and all kinds of stuff. But we just created a new container, and that container had extra label set that would route all requests for www.minemine.nl, and with just slash as a path. And those would go to the that container, and all the requests would then be handled like they would be normally. And at the end of the day, we just killed that container, and that also removed the route immediately. So it was very easy to have a different front page for a day, just by routing a container. That's request routing.
And then the last two ones, updates without downtime. How do you update your application and service without affecting your customers? If you deploy a new version, you want to run this traffic over it when it's healthy, and all the containers should be removed as fast as possible. So, how do you handle it? I'm gonna tell the story for service. So we have the DCOS agents, and then run like 10 containers each host, I guess. And then when we update the instance, we just count how many instances we have. In this example, it's 9, and we created 9 extra. So we have 18 hosts at the time. Then we update the Docker containers with an extra constraint, so they move to the new instances. And then one by one, the containers are moved from the old instances to the new ones. It takes like 10-20 minutes or something like that. And when it's finished, we just double check it. And then all the containers are moved. We just kill the old instances. And we have done the update from the agents, and it's just basically the same for the applications. We have some extra Docker containers with the new version. They become healthy, we watch them a little bit for a minute or something. When they stay healthy, we just kill the old containers, and then the new version is released.
Those were mainly the challenges we had. We have also some afterthoughts. The downsides are the entire environment has become more complex than before. Perhaps it's an understatement. It has a lot of moving parts now. We need to have console running, traffic running. All those things need to be behaving perfectly for it to work well. DCOS schedules single containers. In the last release of DCOS, they added a multi-container concept. They call it pods. I think they looked at Kubernetes for the name. In the beginning, we created multi-process containers, which is something you really don't want to do. Don't do it, because when you have multi-process containers, you need some kind of supervisor or init system in your container, and your container gets rescheduled when the main process dies. Well, the task of an init system is to never die, so your container's health isn't correlated to the main process in the container anymore. So, if possible, create single process containers. No namespacing, so we really needed to set up separate accept and production environments. If there was some kind of namespacing, you could easily have some artificial layer between them. It's not possible. And there are no ACLs in the free DCOS. So if you give someone access to the web interface of DCOS, they are super admin. And anyone that has access can do really anything. So they can kill containers, they can edit other users. So if you give the bad user access, you can lose everything. And also no secrets management. We use Vault for it, but that also has its problems. On the other hand, since we set up DCOS, I think it was running in production about October last year, we've had an increase of 200% of microservices, and that's basically a testament to how easy it has become to launch new microservices. The developers at Mind don't even think about it anymore, they just create a new microservice and they can do everything themselves. All the environments have become very similar, so dev, accept and production are nearly identical, and we have almost no bugs introduced by the environment, which is an amazing difference with how we released before. Now it really is, if it's working on the accept environment and you push it to production, you test it a bit, you click around on the website, but you can really have confidence that it works as you intended. New microservices can be promoted to production in about an hour, with tests maybe a bit more, but it has really become a simple process. And we now run 62 unique microservices on 12 instances. If we would use the old 3 instances per microservice paradigm, we would be running 186 instances now, and we can run it on 12. So also in cost, this has been a major benefit. This is about the setup that is running now. Traffic is a separate label here, but it is running on all DCOS agents. We still have a link with console mainly for configuration and DNS resolving of the stateful services. Now let's show it. This is the DCOS web interface. This is DCOS 1.9, it's the latest release. And you can see this is the page you just, when you first log in, you see this. You can see how much CPU is allocated, your memory allocation. When you look at the right, you see the component health. There are 43 components that need to be running, so it's quite a lot. On the left we have the menu. The services are long-running tasks in DCOS. So your web servers, your revenue consumers run in services. You also have jobs. Jobs run in Metronome. Metronome is basically a distributed cron and it also uses Mesos to schedule the tasks.
Now that you mentioned web service, you're discouraging multi-process containers. How about multi-threading?
No problem. As multi-threading is okay, as long as the parent process basically dies when something is wrong. That allows the container to be rescheduled on other hosts. Any more questions? We'll show more. Yeah?
How do you handle data migrations? Which are rolling updates?
Luckily, we almost have no stateful services that really need database migrations. But we try to create services that can that are at least one version backwards compatible. So when you do a migration, the old release also still works. So when you want to change a column name, you basically have to add it first, and then in the next release, rename it, and then remove the old column, and it's a multi-step process.
So basically, your developers know.
Yeah, they know. There's also Universe. Universe allows you to install packages that are provided by Mesosphere or the maintainers of these packages. Which make it really easy to install distributed services like Elasticsearch or Cassandra. So it's really also kind of an app store. At the node overview view, you can see all the nodes that are running. We have 3 agents in this demo cluster. When you look at a node, you can also see what is running on each node. And you can see the attributes that we have set. These are custom attributes. When we create new instances, these attributes are set in a file on the instance themselves. And the zone is basically the availability zone in AWS. The AMI is the Amazon image with which it was created. We use this to tell the containers on which image to run. So when a rolling update occurs, we can just tell all containers, now make sure you run on an agent that is running this image. And the type and ID are mainly informational so that we can correlate it with the EC2 dashboard. Now we're going to start the service. We have created a little demo service. We're going to scale it to 2 instances, I think. And we can also show the configuration of the container. Can be interesting. We still use the web interface of 1.8 of DCOS. It's a bit, it has changed a little. It won't be as smooth all the time. And here you can see very nice side-by-side the configuration options and what effects they have in the JSON file you provide. So yeah, you can provide your container image, how many CPUs, how many memory, how many instances, what runtime do you want to use, what ports you want to expose to the outside world, how you want to handle your networking. You can define your volumes for semi-persistent storage. You need to really use some external plugin to have persistent distributed storage, but DCOS says it's beta, so and it says don't use it in production, so we don't use it in production, basically. Here you define your health checks. It's just a GET request in this case. It can also be a command you run a container. And there's some environment variables we provide to the container, which allows the container to configure itself correctly. And those labels at the bottom are for traffic, and they determine the request routing. So let's see if the container has started running. Oh, it hasn't. Panic. It's not running, so let's look in DCOS what is going on. It says it is running, no host checks available. So let's, here we can see the task was killed because the health check failed. I know it's wrong. We didn't set it to be healthy. This is the web interface of console. In the key value store of console, we can change the configuration of the container while it is running. So we have a prefix in the console-defined config. And when we change here we see the parameters that are provided to the container. And we said healthy is no. So that makes the container not healthy. We say healthy is yes. That should take care of that. And when we look at the instances, when we view the logs, we can also see what happened. This is the standard output. The lines you see with runner and child, those are comments from console template. So console template is watching the console key value store, and it has rendered the template. This is the template file we provided, that's the output. And as a consequence of its rendering the template, it has started Apache. And you will see that Apache should be running, and the service has also become healthy. So when we go to the hostname we provide that as a marathon label, you will now see a nice demo page. When we make a change in the console key value store, you will see it's nice. This will trigger an update of console template. Console template will re-render a parameters.yaml file, and as you can see, it has already been processed in the container. But this is also a very powerful mechanism, for instance, to change the log level of container. If you have a container that is misbehaving, you can change the log level to debug real time, and you get more output. And when it's behaving correctly, you can just say to warning or error. We also have another service, the date microservice. We use microservices. So everything is a microservice. In this case, we also have a microservice that returns the current date. Very useful. You give developers power and they abuse it. So this is a very nice microservice. If it has become healthy, this microservice will perform a request for the current date. Not becoming healthy. It is running, so it's this service has a graceful failure when it cannot resolve. But in this case, it now provides the date and it's coming from another microservice. This microservice also logs to Elasticsearch, but runs it. It throws an event when it's called, and then it runs a logstash, takes those events and stores it in the events index in Elasticsearch. And as you can see, the events that are logged, in this case there were a lot of errors because it could not resolve the hostname. And the last one is a successful message, and that message also tells you what date and time it provided to the other service. This is of course a toy example, but this really allows us to have very good insights in what is happening in the application. For instance, when new domains are purchased through the Mine website, there is also an event that's thrown, and we can do all kinds of analytics on those events because we really have the real-time data of what is happening on the website. We will also show a bit of Traffic. Traffic also has a web interface. And in the web interface you can see what is configured in Traffic. This is the web interface. On the left you see the backends that are defined in Traffic. Frontends, excuse me. Those frontends have rules for how the requests are routed. So you can see you can also the RabbitMQ web interface is routable to Traffic. We have a demo page in Kibana that you just saw. And on the right you have the backends the requests are routed to. You also see there are two backend instances for the demo service running. And you can see they have random ports assigned, and Traffic routes requests just to those containers. And those ports can change whenever Marathon schedules them. Traffic picks it up automatically. And there's also a health overview, and here you can see what the requests are doing in real time. So you see the average response time, but you also see recent errors that have occurred on TriView. For example, when the container wasn't running, the demo.test.mine.nl could not be found. So you see a very nice 404 error. When we want to change the route in TriView, it's very easy. You just go to the service. And we change the label. This says, for the container itself, it has no consequences, because the container cannot view the labels that are assigned to it. Here we can see that we change it to enlucht.test.mijnmijn.nl, and this will perform a rolling update. So a new container is scheduled. When that container has become healthy, an old container will be killed, and when a new container will be scheduled, when that becomes healthy, another container will be killed. It's a very robust mechanism, and because TriView is watching this real time, requests always get routed to healthy instances. So if all went correctly, we now can use enlucht.test.mijnmijn.nl, and demo.test.mijnmijn.nl isn't resolvable anymore because we changed that label and the old containers are now killed. That was about it. Any questions?
If you were to build the environment from the ground up, would you still choose for DCOS the same mechanisms, or then go for Kubernetes anyway?
I would still go with DCOS for now. The web interface really has so many benefits for us that it's really worth it, even though Kubernetes does have some advantages to this system.
Is it the commercially supported product, or is it your own?
We use the free DCOS, but there's also enterprise DCOS that is supported by Mesosphere, and then you also get support. Any questions? The slides and code are on GitHub, and you can view them if you want to see them again. Yes.
One more, persistent storage, is it part of DCOS, or?
No. No, they have they provide plugins for persistent storage. They can use stuff like Ceph or ClusterFS, but they say it's not mature enough yet to use in production. On the Slack channel of DCOS there is always talk about it, but nobody is really certain enough to use it yet. Thank you for your attention.